Alright, let's keep it rolling with constant of proportionality. So let's fill in some blanks here and get some vocab going. So rate of change is a rate that describes how one quantity changes in relation to another quantity, which we've already talked about, right? That's just what it is called, is rate of change. So the rate of change tells us the constant of proportionality, and sometimes you'll hear it abbreviated to constant, but it's the constant of proportionality, and that's in proportional relationships. And this is because the rate stays constant in a proportional relationship. So just to be clear, you could have a rate of change that doesn't necessarily mean that the relationship is proportional. But if you have a proportional relationship, then the rate of change is constant, which means you're going to talk about the constant of proportionality. Now, we've already talked about this, but just to show you more specifically, so if there is a proportional relationship between x and y, which is what we've been talking about over and over and over again, you can describe that relationship using the equation y equals kx. We already did this, right? Remember when we always said it was write an equation of expressing y in terms of x? That's what this is saying. The k stands for constant of proportionality. Now, the reason we don't use c is already used for a different term in math, but so k is constant. That was the next closest one. Anywho, but it's always going to be y equals, and then something being, I know, sorry, Cora's barking again. K is being multiplied to x. So it's always a multiplication situation when we're talking about proportional relationship. So anywho, the variable k is called the constant of proportionality, and it represents the constant rate of change or constant ratio between x and y. And usually it's fairly easy to see, but sometimes it's not. And so here is a neat trick, and I already kind of told you this in the last video. So the value of k, so to find the constant, the number for the constant of proportionality, so the value of k, that can be found by using the equation k equals y over x, which really just means you're taking y divided by x. And the way they got that is they solved for k here. So they divided both sides by x, and you end up with y over x is the same as k. That's how you got that, okay, just so you're aware. But essentially it means that you're taking y divided by x to get whatever k is. Okay, because sometimes k could be a whole number or a fraction or a negative or whatever, but that's how you could find it if you're not sure. So let's first, hold on one second, gotta do something. Sorry about that, I had to fix that. I didn't show you all the answers right away. Okay, so we're gonna first focus on what is the constant of proportionality for all the equations, right? And so if you just follow that equation, remember it's y equals kx, where k is the constant of proportionality. So all you're really looking for is what's the number being multiplied to x. That's it. Very, very simple. So the constant of proportionality for this first one is 25. Okay, the next one is 1.5. And if I'm going too fast, feel free to pause the video, go back and take a look at something, but I don't want to waste your time. And so whatever that number is being multiplied to x, that's our constant. Very simple. Okay? Even though this is flipped around, we can still figure out whatever's being multiplied to x, in this case 2/5. So that's our constant. And our constant in this case is -4. Okay, it's just the number being multiplied to x. That's what the constant of proportionality is. Okay? Alright, so in tables and graphs, okay, it's the same idea, it's just we haven't written the equation yet. And if you notice, I had a little mistake here, so go ahead and fix this. Instead of 146, change it to 156, just because we want to make sure it is a proportional relationship since we're talking about the constant of proportionality. So all you really need to do with tables and graphs is figure out, well, what is happening each time. Okay, so like what are you multiplying by each time? So if you look at this one, you're doing 2 times 13 to get 26, and it would need to keep doing that the whole way. That's how I knew I made this mistake here by accident. I forgot to change it from last year. So you do 3 times 13 gives you 39. Now if you get to higher numbers and you're not sure, you can always use your calculator and just do 6 times 13. Does it give you 78? Which it does. And again, when we got down to here, 12 times 13 gave us 156, not 146. So that means our constant is 13. K equals 13. Okay, so we're going to do the same thing on our graph here. Now, it might be hard for you to tell. Now, you might be able to figure out what you're counting by, and that would help, because the way to figure out a constant on a graph is you want to try and find where 1 is for your x, and that will tell you what your what it is for y, which is what you're multiplying by each time. But if you can't find that, you can always go to another point, like on this one, for example. If my x is 2 and my y is 10, remember you can always take y divided by x to equal your constant, and so 10 divided by 2 gives us 5, and if you think, well, here's 1 and then 5, because that's between 0 and 10, so our constant is 5. Okay, real simple. But you can always figure it out if you're not sure. You just got to take the y and divide it by the x. Okay? One more. We got a real world situation here. So again, you're just trying to find the connection of what's happening. So it says Callie earns $48 for 3 days of dog sitting. What is the constant of proportionality? So what are you doing to the 3 days to get to the $48? If you're not sure, you can always work backwards. If our dollar is our dependent, which is the y variable, and days would be our independent, which is x, you can take 48 divided by 3, and if you do that, you get 16, which is our constant of proportionality. Okay? So you've got a quick check to go get. I'm sure you'll do just fine, and then you're moving on to 1D. You got it.